All right, hello grade 10s. This is our second lesson of our last unit, trigonometry. So I would really like for you to pause it and fill in the blanks here. You can just do it on scrap paper or whatever. And this will just make sure that you know what's going on from last lesson. Okay, so I'm going to go ahead and assume that you paused it. So our reference angle is x. That's indicated by this little swoop here. So our opposite side would be side x, and in this case, that is 8 centimeters. I'm going to skip the adjacent because that's the hard one. The hypotenuse is 10, obviously. It's the longest side, which means the adjacent side has to be 6 centimeters long. Okay, now we're going to go through what sine x, cos x, and tan x are. Again, this is a review from last time. Just remember Sohcahtoa. So the sine of x is going to be the opposite O over the hypotenuse h. The opposite is 8. The hypotenuse is 10. Cos of x is going to be the length of the adjacent side, which is 6, over the hypotenuse. I'm getting that from here, which is 10. And finally, tan is toa. T is for tan, O for opposite, A adjacent. So opposite 8 over adjacent 6. Okay, so let's get into it here. This is just a quick little recap. Sohcahtoa, remember? You gotta remember that. This just tells us stuff from last time. Again, you can pause it and copy this down if you want. I think it'll become pretty routine for you, hopefully shortly. Cos, adjacent over hypotenuse, or the calf, and tan is the opposite over the adjacent, or the toa. So today, for the first time, we're actually going to do some practice with this stuff. Okay, so here it is all on one slide. Again, you can pause and write this down if you need to. Okay, so we just got 3 or 4 problems here to start, and then I'm going to have you do some practice. So we've been asked to find the value of r and of q. So I'm going to do r first in red. All right, so this is the procedure. First, this is my reference angle, which means that this is my opposite side. This is my hypotenuse, and that means this is the adjacent. So to find the length of a side, we always need our reference angle. We need to know what the number is, which we do. It's 35. We also need to know one other side. In this case, we know the opposite, and we're looking for the hypotenuse. So I write Sohcahtoa, and then I see for side r, which one of these pairs of sides do I have, or am I interested in? So I have the opposite, and I want the hypotenuse. So I'm dealing with O and H. So I look through Sohcahtoa, and I find which one of these has O and H, and I can see that it is sine. So this is the procedure. This is the first time you've done this, so if you're a little lost, don't worry. I'm going to do this a bunch of times. So I'm going to write side r. I identify that it's sine, so I'm going to say sine 35 degrees equals the opposite, which is 7.6, over the hypotenuse, which is r. So you can see here that we only have one variable, one unknown that we need to find. I also want to point out that sine 35 is actually just a number. So this is the first time you've done this part, so you need to make sure that your calculator is in degrees. So I'm going to go to a scientific calculator.
David is just recording.
So if we go to the scientific calculator, we can find sine 35. Now it's important that we're in degrees. So you can always check this. On my one-line calculator, I would type 45, and then I would push sine. And it looks like it's a drop down here. And if I get 0.707 for sine 45, I know that I'm good. Now if you have a two-line calculator, you would push sine, and then 35, and you can see that that didn't work for me because I have a one-line calculator. If you're using your phone calculator, you might have to type the angle first. So again, sine 45 should be 0.707. So check that on your calculator before we move on. Okay, back to the problem. The issue that we have here is that our letter is on the bottom. So what we want to do is we want to bring it up top. Let me show you the long way first. So we multiply by r on both sides, and that's going to get rid of the r over here, and now it's up top. Now, to get r by itself, we would divide by sine 35. So if we divide by sine 35 on both sides, these would cross out, and we would have r equals 7.6 divided by sine 35. Now let me show you the shortcut. I just wanted to make sure you understood why the shortcut works. So instead what we do here is if our variable is on the bottom, we just switch these two. So the r comes up, and the sine 35 comes down, and you can see that that is exactly the same as what we started with, okay, when I did it the long way. Now, to do 7.6 divided by sine 35, I'm going to have to do this. 7.6 divided by, now remember, on my one-line calculator, I have to hit 35 first. So divided by 35 sine, and whenever you do this, you're going to get a 0-point number for sine or cos, and that's not your answer. Right now, my calculator is just showing me 0.57. That is not the length of this side. And if you look at the triangle, that's obvious, right? This is 7.6, so the hypotenuse has to be bigger than that. So now I just have to hit equals, and now I get 13.25. So r equals approximately 13.3 centimeters if I round it. And if you look at the triangle, I think that makes sense. If this is almost 8, then this being 13 is reasonable. Let me show you the calculation again. From here, 7.6 divided by sine 35, but I do 35 sine. And then I hit equals, and I get my answer. Now be careful, because if I keep hitting equals, it's going to keep doing stuff, and it's going to get really crazy. So use your calculator until you get 13.3 to make sure that you understand how to do it. Okay, now we're going to solve for side Q. Now some of you might notice here that you can just use the Pythagorean theorem from grade 8 or 9 once you have two sides, but I'm going to do this with trigonometry because that's the unit and because it's quicker. So if we're looking for side Q, we have the opposite, and we want the adjacent. So for side Q, we're dealing with O and A. So I look through Sohcahtoa until I find O and A, and I find it here. So to solve for Q, we do tan instead of sine, it's still 35, equals the opposite, which is 7.6, divided by the adjacent, which is Q. Again, the variable's on the bottom, so we have to switch everything. Well, not everything, but we switch these two. So Q comes up, tan 35 goes down, and Q equals 7.6 divided by 35 tan, or on your two-line calculator, tan 35, and then I hit equals, and I get Q is approximately, I think it was 10.85, yep, so approximately 10.9 centimeters. And again, if I look at the triangle, that answer makes sense because this side is shorter than the hypotenuse. So that's it. That's how you do these things. I've got a couple more examples I'm going to do with you, and then you're going to do some practice on your own. And if you're finding my explanations aren't enough, just search like right-angle trigonometry in YouTube, or search Sohcahtoa on YouTube, and that should be enough. Okay, so now we've been asked to label the sides with the appropriate letters and then find the length of the missing sides. So obviously this is side F. We don't need the F because it's 9.8, but I'm going to put it anyway. This is going to be K because it's opposite, and across from E is little e. Okay, so now let's go ahead and let's solve for a missing side. I'm going to solve for side E first, for no reason other than I looked at it first. If we're going to do this, this is our reference angle. Don't forget Sohcahtoa. It's going to tell us what ratios we're going to use. So from this angle, we want the hypotenuse. Sorry, we have the hypotenuse, and we want side E, so we want the opposite. So we're dealing with O and H. So we look at Sohcahtoa until we find the one that has O and H, and it's sine. So sine 62 equals the opposite, which is E, over the hypotenuse, which is 9.8. Now this one's a little different, and this is actually the easier type. Because the letter's on top, that's where we want it, it's being divided, so this time we just multiply. So when the letter's on top, we multiply, And you might have noticed in the other ones, when the letter was on the bottom, we ended up dividing. That's usually the way students remember this. These cancel out, and E is going to be 9.8 times 62 sine, and then I hit equals, 8.65, so approximately 8.7 centimeters. And again, that makes sense because this is shorter than this. Okay, and remember, on a two-line calculator, it's going to be a little bit different. So just make sure you run this calculation until you get the right answer. Okay, so now we're going to do side K. And again, some of you are probably thinking I'm just going to do the Pythagorean theorem. And technically, that's fine. I encourage you to practice some of this because you haven't really seen it much before. So if we're looking for side K, that's the adjacent side. We have the hypotenuse, so we're dealing with A and H. And if we look at Sohcahtoa, we see that Ka is the one we want, so we're dealing with cos. So cos of 62 equals the adjacent, which is K, divided by the hypotenuse, which is 9.8. And I would like you to think about this. In this case, am I going to multiply or divide to get my answer? The letters on top, we're dividing by 9.8, so in this case we multiply. And remember, the trick is when the variable's on top, you like that, and you're going to multiply, which is easier than dividing for some reason. And now we do 9.8 times 62 times 62 cos. We hit equals, we get 4.6, approximately 4.6 centimeters. And again, that's shorter than the hypotenuse, so that checks out. The other trick in a triangle is if you add the two legs, so the two non-hypotenuse sides, they should add up to more than the hypotenuse. Because if you imagine that K is like Kyle's house and E is Earl's house, the shortest distance is to go in a straight line between the two. So if you took this road and then this road, which are these two, if you added those up, that would be a longer trip than the direct route. So that's another way to check. Both of these individually have to be smaller than this side, but if you add them up, they need to be longer. Okay, moving on. I think this is the last question I'm going to do, and then I'm going to have you do the rest for practice. All right, so label the letters again. So across from A, we got little a. Across from W, we've got little w. So we're going to solve for side A, we're going to solve for side W. The order doesn't really matter. I'm going to solve for side A first, because why not? All right, so if we're going to solve for side A, this is our reference angle, because it's the angle we know. And some of you might be thinking, well, couldn't we find this angle by subtracting from 180? And you could, but you don't need to. If you have an angle and a side, you have everything you need. So here we go. This is our opposite side, so we want the opposite. And this time we have the adjacent side. So I go back to my old friend Sohcahtoa, and I see which one of these has O and A, and it's Toa. So tan of 15 equals the opposite, which in this case is letter A, over the adjacent, which is 9.8. And all that's left now is the calculator step. Our letter's on top, so we multiply to cancel those out. These cancel, and we get 9.8. Oh, 9.8 times 15 tan. Remember, on a two-line calculator, you'll just type tan 15. I hit equals, and I get A is approximately 2.6 centimeters, which is, I mean, it doesn't really look like that because these diagrams aren't to scale, but that's reasonable, right? It's a reasonable number. It's not 150, it's not 0.01, so that seems like a reasonable answer to me. And now for side W, again, you could use the Pythagorean theorem, but why would you? So this is still our reference angle. This time we're looking for the hypotenuse. I'm going to put a little h over here, and the side that we have is 9.8, which is the adjacent side. So we need H and A. Now I purposely wrote these in the wrong order just to show you that it doesn't matter. So I go up here and I find which one of these has an H and an A, and obviously it's cos. And you're going to get pretty good at this pretty quick, and you're not going to have to write Sohcahtoa every time, but for the first bit I find it helps. So if we're using ca, we're going to have cos. The angle's the same, so cos of 15 degrees is going to be the adjacent, which is 9.8, divided by the hypotenuse, which is w, which is the side we want to find. So if you set this up and you had numbers everywhere, well, there's really no point to that, because if you don't have any unknowns, then there's nothing to solve. So make sure that the letter you're looking for always ends up in this ratio. And now I want you to ask yourself, am I going to multiply or divide here? So I encourage you to pause it, maybe even try this one, work it all the way through, and then check your answer. All right, I'm hoping that you paused and tried it. So in this case, W's on the bottom, so we have to switch these guys. You might have heard that called cross multiplication. Doesn't matter what you call it, it does work, and I showed you earlier why it works. Okay, so we have 9.8 divided by cos 15, so 9.8 divided by 15 cos on my one-line calculator. I hit equals, and I get W is approximately 10.1 centimeters. And again, that makes sense because it's the hypotenuse, so it has to be the longest side. And I can always check by adding this and this together, and they should be more than 10.1, and they definitely would be. Okay, so this makes sense to me. All right, these answers make sense. I hope the calculations are okay for you. It might take a bit of practice, but you should get there. And here is your note for today. So to solve for sides in a right triangle, step 1, decide if you're going to use sine, cos, or tan, and you're going to do that with Sohcahtoa. And it all depends on what side you have and what side you want. Set up your trig ratio using sine, cos, or tan. Again, Sohcahtoa. Plug in your values and evaluate to 4 decimal places. So I'm going to change that. So we're going to say plug in your values, and then I'm going to say solve on your calculator. That was a remnant of an old lesson where I did this a little differently, but I think this is a little easier now. So I'm going to say if the variable is on the top, multiply. If the variable is on the bottom, divide. And you know what that means if you've watched this lesson, and just make sure you practice it. Okay, so let me show you the homework here. So this first part, it just says to round to 4 decimal places. So this is super easy. This is literally just 65 sine, or sine 65. So this would be 0.9063. So the answer here is 0.9063. This is just to have you practice using the sine, cos, and tan buttons on your calculator. All right, and then here you're going to determine the lengths of the missing sides, and you're going to show your work. Again, do this on scrap paper. If you have a printer, print out the handout, even better. But you're going to start by calling this little v, and this is going to be side little g, and you would just go from there. All right, you'd find your reference angle. This would be the opposite. This would be the hypotenuse, and this would be the adjacent. And then you'd go from there. Okay, and the next one, triangle SCM. Again, you label the sides, put in the reference angle, you get your Sohcahtoa going, and solve it. I will show the solutions to these at the end of the day, like I always do, and you can check your work. Next one is, again, pretty straightforward. The triangle is on its side. Shouldn't really matter. Just remember that this is the hypotenuse still across from the 90. And then I've got one where you actually have to draw a triangle PBJ. So you draw a triangle PBJ. Be careful with the angles. This is the right angle, so that should help. And I tell you side J. And then you solve for P and B. And again, I'll show a solution. And finally, find the length of side X. So just one side. So this is your angle. What sides are you dealing with? Sohcahtoa to figure out what you're supposed to do. And let's just check through to make sure I've gone through all the homework questions you have. There are 2 more at the end there, number 6 and 7. And I will make sure to add those to my file. I'm not sure where they went, but there we go, 6 and 7. So in number 6, again, you're just solving for the one side. And in number 7, it's a word problem. So he's got a 6-meter long ladder. It shows a 50-degree angle. So let me just redraw this triangle for you. Looks like this. This is a 90. This is 50. This is 6 meters. And they want to know this height here. Okay? So nothing crazy. It just starts with a picture. Okay, so good luck with that. Again, if you have any questions, please let me know. I'm always happy to help, and I'm happy to do a Google Meet if that's what you want. All right, thanks, folks.